Welcome back everyone for yet another video on trigonometry. What we're going to be doing in this video is taking a look at how we can solve for angles and sides for non-right triangles. And in this video we're going to be looking at the sine rule specifically, and we're going to see as long as you understand what the ratios are asking you for, you're going to get the right answer every single time. So let's go ahead and dive right in. So for this video we're going to look at the sine rule. So what exactly is the sine rule? So just to kind of point a frame of reference, we have a triangle ABC right here, okay? And then the angle measurements are denoted with a capital letter, capital A, capital B, capital C. And then if you notice that the corresponding side, the opposite side, is going to have a lowercase c. So if I have capital A over here, I go to the opposite side, I have a lowercase a, capital B over here, opposite side, lowercase b. And that's going to be very important to remember, because what the sine rule tells us is that if you take the ratio of the side and the corresponding angle, the sine of the corresponding angle, and you equate that to, well, one of the others, whether it be B or C, as long as you know two out of those three variables, you can go ahead and rearrange it and solve for your unknown variable and get the answer that you need. So when you are using the sine rule, you're going to want to use two angles and one side. And you're also going to need to know that the known side and angle need to be opposite each other, as we just discussed. So for instance, A over sine A, that means I need to know this length, and then maybe I don't know how long B is, but I know what the sine of B is. Therefore, I could rearrange my equation just as we did in previous videos and solve for our unknown variable. But let's take a look at an example. So as best practices go, if you're given a formula booklet or you're not, you should always write the rule. I always like to write SOHCAHTOA in my top right-hand corner of these kind of problems. But in this case, I would actually write the sine rule as well, just to make sure that I'm not worried about that and I'm more worried about the problem. So in triangle ABC, we're given that the little b, which is the length of one of the sides, is 16, the length of the C is 10, and then the angle B is 135 degrees. Find the size of the remaining angles in the triangle. Now, and in these kind of problems, it's always best to draw these out with the diagram. It makes it much, much, much easier to work with. So I'm going to draw a 9 right angle triangle, and of course, these might not be to scale exactly, but I'll go ahead and call this A, call this B, call this C. So I know that little a, actually I don't know what little a is. I know that little b is going to be 16, it's going to be this right here. I know that little c is going to be 10, and remember that's because it is the corresponding side, which means that if your angle is here, that corresponding side is opposite, same thing here. And I know that b is going to be 135 degrees. So now I want to find the remaining angles in the triangle. So it might be easiest to do is set up a sine rule, and that way I can find out my other angle, because obviously in a triangle, the sum of all your interior angles must be 180 degrees. But you have to have two angles in order to do that, and I only have one, so I got to find this other one by using the sine rule. So if I have the value of little a, which I don't, so that means I'm going to kind of sort of ignore that for right now. I know that I have angle B in the side of B. That means this is going to be appropriate. And I know that I have the angle of, I know that I have the side length of C, which means that I can therefore find the angle of C. Now, let's write this out. Little b, which is going to be 16, all over the sine of b, that's sine of 135 degrees. That's going to be equal to little c, which is 10, all over sine of c. Now, I want to know what c is, the sine of c. I want to know what that angle is. So what I can do is rearrange this just as we did in our previous problems in order to get that unknown variable. So let's go ahead and get it to the other side. So that way I would have the sine of c times 16 all over the sine of 135 is equal to 10. Then I want to take all of that over, so I can have 10 sine of 135 degrees all over 16. Then I'll take the inverse sine as we did in previous videos, which means that the inverse sine, remember this is the angle of C, is going to be 10 sine of 135 degrees all over 16. Put that into your calculator, and what you're going to get out, at least the three significant figures as we do in this course, is going to be 26.2 degrees. So I'll put that in there as 26.2 degrees. All right, and then what is going to be my other angle? As I previously stated, the sum of all the interior angles of a triangle must be 180. So 180 must be equal to 135 plus 26.2 plus whatever my angle A is. And what does that going to give me? That is going to give me 18.8 degrees for A. So again, I can kind of consolidate everything here. I have 18.8 degrees for A, I have 135 degrees for B, and then I have 26.2 degrees for C. That is going to give me all three of my interior angles on this triangle by using the sine rule and an old property that we learned a long time ago about those interior angles equaling to 180. That's going to be it for this video. In our next one, we'll take a look at a couple more example problems to make sure that we really understand what is being asked in terms of the sine rule for this course. Take care, and I'll see you all in the next video.